Okay, what we're going to do is we're doing 6.5. We're going to do 6.5. All right. Let me get my pencil here. Okay. We're going to look at 6.5, which is the last section in chapter 7, or in chapter 6, sorry, last section in chapter 6, and it is about solving quadratic equations. Now the difference is we've looked at something like this, and you've been asked to factor it. Now it's going to be equal to 0. Now it's an equation. There's an equal sign. I must solve for x. Okay? So that's the difference, what we're doing today. The first thing when you are solving is you get everything on one side, 0 on the other. Do I have everything on one side equal to 0 on the other? Yes. Then I take that everything and I have to factor it. All right, 3 pieces, easy kind. What multiples of 6, which ones add up to 5? Well, it would be 2 and 3. And to get a positive 5, it would need to be positive 2 and positive 3. Now, that's the easy part. It's already something you know how to do. Everything on one side, 0 on the other. You know how to move things around. And then factor it into something that's being multiplied. You know how to do that. We've done that in 6.1, 6.2, 6.3, and 6.4. Now, the next step I need to explain to you. You're going to take each piece or each multiple and set each piece, or what we call each multiple, equal to 0. The reason why is if you had A times B equal to 0, A could be equal to 0 or B could be equal to 0. As long as one of those are equal to 0, your answer would be 0. Okay? So x plus 2, as long as whatever's inside there equals 0, or as long as whatever's inside here, x plus 3 equals 0, when I multiply, my answer will always be 0. So you take each piece and you solve for x. So x is negative 2, or x is negative 3. With quadratic equations, you have 2 answers because the highest exponent tells you how many answers you should have. So we need to have 2 answers. If x was negative 2, you'd get 0. If x was negative 3, you'd get 0. All right? Let's go over that again. Go over that again and think about what I just did. All right? The first thing I did, as I said, everything on one side, 0 on the other. Then I factored everything. Then I set each multiple equal to 0, and I solved for the variable. And you should have 2 answers if it's squared. Okay? All right. So what if I had 2x squared plus 3x equals 2? All right? The first thing I have to get is everything on one side, 0 on the other. So I need to move this over. And the way I move it is I subtract it. So I get 2x squared plus 3x minus 2 equals 0. Now I need to factor. There are 3 pieces, but it's not the easy kind. It's where we have to rewrite. We take the outside numbers, multiply them, and we get 4. So how do I rewrite 4? 4 is either 4 times 1 or 2 times 2. Which one of those sets subtract to give you 3? This. So if I rewrite 3x using 4x and 1x, I have to say 4x minus 1x. 4x minus 1x would give me 3x. Now, how many pieces do I have? I have 4. So I group, and the middle is a negative, so I group it on the inside to remind myself that I have to take it out negative. All right, what can I divide out of 2x squared plus 4x? I can divide out a 2x. So if I take a 2x out, what am I left with? X plus 2. Now what can I take out of 1x and negative 2? There's nothing in common except for the 1, and I have to make it the negative. Whatever you take out, it has to be negative. So that gives me a positive x and a positive 2. So what do they have in common? X plus 2, and what's left? 2x minus 1. Now it's factored. Now I set each piece equal to 0 and solve. Okay, so let's come up here. X plus 2 equals 0. Move the 2 over. I get x is negative 2. For 2x minus 1 equals 0, I'd move the 1 over, and I get 2x equals 1. And then I divide by 2, and I get x is 1/2. So my answers are negative 2 and 1/2. All right, let's try another one. Look at another one. And you'll start to see the pattern. Okay. What if I had 4z squared minus 20z equals 0? All right, is everything on one side 0 on the other? Yes. Now I need to factor. Well, I only have 2 pieces, but what is the first rule of factoring? What can I take out? What can I take out here? I actually could take out a 4 and a z. If I took out a 4 and a z, I'd be left with z minus 5. I still have 2 pieces, this times this, so it is factored. So I set 4z equal to 0, and I set z minus 5 equal to 0. When I divide by 4, z is 0. So 0 is an option. That's one answer. And if I move the 5 over, I also get 5. So z could be 0 or z could be 5. What if I had 3m squared minus 108 equals 0? Is everything on one side 0 on the other? Yes. Now I need to factor it. What's the first rule of factoring? Well, the first rule of factoring is what can I take out? I could actually divide a 3 out of both sides. If I divide a 3 out of both sides, I'm left with m squared minus 36 equals 0. Now, look at this. It's 2 pieces. These 2 pieces couldn't go any farther. It was just a z. But this is an m squared. This is a special kind. This is the difference of 2 perfect squares. So if you remember, you get m and m. That's the square root of m squared. The square root of 36 is 6. And then you had a plus and a minus. Now, you have this times this times this. So you set each piece equal to 0. But when you set 3 equal to 0, that doesn't even make sense. So it's kind of, it just gets washed away. It's gone. Here, you had a 4z on the outside. It had a variable, so you actually could solve. This is just a 3, so it just goes away. M plus 6 equals 0. So m is equal to negative 6. And m minus 6 equals 0. So, what happened? Uh-oh. Where did everything go? So m is equal to, wow, I didn't know I could keep going down. Look at that. Well, look at this. I don't have to get a new whiteboard. I can just keep going down. Wow, learn something new every day. All right. This one is a little bit more difficult. What if I had something like this? Now, is everything on one side 0 on the other? No. But can I even move it the way it is? No. I have to undo everything, move things over, and then redo them. In other words, 2x times x is 2x squared. 2x times 1 is 2x. 1 times x is 1x, and 1 times 1 is 1. 2 times 1 is 2, and 2 times negative x is negative 2x. All right, on this side, combine like terms. I have 2x squared plus 3x plus 1 equals, combine like terms here, 8 minus 2x. Now I can move everything on one side, 0 on the other. So I'm going to move the 8 over, and I'm going to move the 2x over. So that I get 2x squared plus 5x minus 7 equals 0. Now I need to factor. Well, this is not the easy kind. So when you multiply 2 times 7, you get 14, which is 1 and 14, or 2 and 7. Which one of those subtract to give you 5? 2 and 7. So we're going to rewrite this. To get a 5x, I would have a 7x minus a 2x. I rewrite it. Now I have 4 pieces, so I group, and I group that negative inside to remind me that whatever I take out negative. Now the only thing I can take out here looks like an x, so I'm left with 2x plus 7. And I can't take anything out of 2x minus 7 except for that negative 1. So I take a negative 1 out, and it gives me 2x plus 7. So this factors as 2x plus 7 times x minus 1. Now, ooh, look at this, I can keep going. That's cool. Now I set each piece equal to 0. Here I'd move the 7 over. I get 2x equals negative 7. Divide by 2, and I get x is negative 7 halves. Here I move the 1 over, and I get x is 1. Okay? So sometimes it's going to take a little bit more work. All right? One more thing that could happen is you could have something that looks like this. Well, you don't have everything on one side, 0 on the other. So the first thing we're going to do is move that over. When we move it over, it becomes a negative. Now, what's the first rule of factoring? What can I take out? I can take an x out. I can take an x out of each piece. I'm left with x squared minus x minus 6. Now, this is still something that can factor. This can go further. You have the easy kind, it's x and x. What multiples of 6 subtract to give you 1? 2 and 3. And to get a negative 1, you'd have a negative 3 and a positive 2. Now we're going to set each piece equal to 0. And this one actually gives me an answer. Not like if it was just a number on the outside, it's a variable. This one gives me an answer. And this one gives me an answer. I have 3 answers, but look at the highest exponent. How many should I have? 3. So that might happen as well. All right. Now, something else they do is they have word problems. Okay? So let me write this out. I'm going to have a piece of sheet metal, and it is a parallelogram, okay? The larger sides are 8 meters longer than the shorter sides. The area is 48 meters squared. Now, oh no, I'm sorry, it's not a parallelogram, it is just a rectangle. How do you find area of a rectangle? Area of a rectangle is length times width. That's how you get area. Or longest side times shortest side equals area, okay? Well, what do we know about the larger side and the shorter side? Remember I told you whenever they talk about something blah, 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 blah than the shorter side, that's what gets the x. Now go back. The larger side is 8 longer. So the larger side is 8 meters longer. Now, if we take the longer side, x plus 8, and multiply it by the shorter side, x, we get the area of 48 meters. Now, if this was equal to 0, we'd know how to solve it, but it's not. So we have to distribute, multiply. X times x is x squared, and x times 8 is 8x. And then we have to move the 48 over, because whenever, in order to solve, remember you have to have everything on one side, 0 on the other. Look at this, and I'm just going to get to keep going. Wow. All right. So, easy kind. We have x and x. Now, what multiples of 48? 3 times 16, 4 times 12. Which ones subtract to give you 8? 4 and 12. To get a positive 8, I would need plus 12 and minus 4. So I set each one of these equal to 0. I get 4 and negative 12. Well, we're talking about find the side. Can a side be a negative number? No, it can't. So the only thing we can do is use the positive 4. So we know the shorter side is 4, and the longer side is 4 plus 8, which is 12. Okay? Now, one other type of word problem that you might get is like, okay, it's like this. It says, think about a rocket. Think about a rocket. If you shoot a rocket, say here's the ground, you shoot a rocket up in the air, it's going to go up, 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 and then it's going to come down. Okay? Now, what they're going to do is they say, if a small rocket is launched vertically, straight up, from ground level with an initial velocity of 128 feet per second, then its height in feet after so many seconds is a function defined by. They give us the height is defined by negative 16t squared plus 128t. They will always give you the function. T stands for time, and H stands for height. So its height is equal to negative 16 times however many seconds it's in the air plus 128, or seconds squared, plus 128 times how many seconds. Okay? Now, using this, they want you to add, they ask after how many seconds will the rocket be 220 feet in the air. So they're giving us a height of 220 feet, and they want us to solve for time, or t. We can do this. It is a quadratic equation, something squared. We get everything on one side, 0 on the other. So I'm going to move this over, and I'm going to move this over, so that I get a positive 16t squared, a negative 128t. I already have a positive 220, and they're all equal to 0. Now, we need to factor. And the first rule of factoring is, what can you take out? Let me see something. Does 220 divide by 16? No. But everything at least, I think, divides by 4. Divided by 8? No. 220 divided by 4? Yes. We can take a 4 out. So we can do it this way. You can just divide everything by 4. This is another little shortcut, okay? So you get 4t squared minus 32t plus 55 equals 0, because 0 divided by 4 is still 0. Now, the worst part is we have to figure out how to factor this. So we have to multiply 4 times 55, and we get 220. Now, what multiples of 220 add up to 32? Well, does 22 times 10 give me 220? Yes. And does 22 plus 10 give me 32? Yes, it does. So I can rewrite this. To get a negative 32, I need a negative 22t and a negative 10t. Now, if you notice, once you do that, you have 4 pieces. So you group. What can I take out of the first set? Well, oops, give me the pencil. No, I want the pencil. Okay. I can take out a 4 and a t. If I take out a, oh no, I can't take out a 4t. No, I can take out a 2t. 2 and a t. If I take out a 2t, I'm left with 2t minus 11. Here, I can take out 5, and I have to make it negative. If I take out a negative 5, I'm left with positive 2t minus 11. So what do they have in common? 2t minus 11, and what's left? 2t minus 5. Now, what do we do next? We set each piece equal to 0. So 2t minus 11 equals 0, and 2t minus 5 equals 0. Here, I move the 11 over. I get 2t equals 11. Divide by 2, and I get 11 halves. Here, I move the 5 over, and I get 2t equals 5. I divide by 2, and I get 5 halves. So I have 5 halves, which is 2.5 seconds. And I have 11 halves, which is 5.5 seconds. So I actually have 2 answers. Now, how does that work? How is it that I have 2 answers? Well, it wants to know how long will it take till I'm 220 feet off the ground. So after 2.5 seconds, I'm 220 feet off the ground. But I keep going higher and higher and higher and higher, and then I have to drop. So I hit 220 feet again. This was at 2.5 seconds, and this was at 5.5 seconds. That's why you can have 2 answers that are positive, because it's a rocket. It's going up, 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 and back down. And it goes higher than 220 feet, so it's going to pass the 220 feet mark twice. Okay, that's 6.5. And with that, we are done. All right, bye-bye.